We'll look at the calculated activity problems, just the sample calculated activity problems that I posted for my class on Campus Cruiser that deals with exponential functions, also logarithmic functions, and equations as well. Problem number 1 says to make a graph of the exponential function f of x is equal to 4 times 3 to the x minus 1, then minus 5, and find the x-intercept and the y-intercept. So here, this is the function we're going to be graphing on the graphing calculator. Right, in this case here, we're going to go to y equal, and then we're going to type in that function 4, and then times 3 to the x minus 1. Now the exponent is x minus 1, so we hit the caret key for the exponent. Now x minus 1 is your exponent, so I'm going to put the x minus 1 in parentheses. So left parentheses, then your xt theta for your x minus 1, and then close to parentheses, and then finally minus 5. And then to do the graph, to be on the safe side, I'm gonna press zoom and then select number 6, because what zoom 6 does, it gives you the standard window. So here, this is what the graph of f of x is equal to 4 times 3 to the x minus 1, then minus 5 looks like. Now from this, we want to find the x-intercept and the y-intercept. Let's first find the x-intercept, because we want to find the point where this graph crosses the x-axis. So we'll press second and trace. And then we want to find the 0, which is the same as your x-intercept, so you'll select number 2. And then you should get a message that says left bound. Now you want to put the cursor below that x-intercept, and then press enter. Then for right bound, you want the cursor to be above the x-intercept, and then press enter. After which you'll press enter again, and that's going to be your 0 to 2 decimal places, which is 1.20. So in this case, our x-intercept would be 1.20 and 0. I'm sure they just want x is equal to 1.20 for an answer. Now let's find the y-intercept. The y-intercept is always going to be the point where the graph crosses the x-axis at x is equal to 0. So we know at x is equal to 0, we want to find out what that y value is going to be. All right, in this case here, we're going to press second and trace. And we're going to select number 1 for the value, because we want to find what the y value is when x is equal to 0. So we're going to select number 1. And our x value is going to be 0. Okay? Because the y-intercept is going to be 0 and some number as an ordered pair. So x will be equal to 0, so you enter the 0 and then press enter, and you'll get the y value of negative 3.67, rounded to 2 decimal places. So here our y-intercept will be 0 and negative 3.67. Okay, so that's how we find the x-intercept and the y-intercept of that particular graph. Question 2 is finding the balance on an account after 8 years if $12,000 was invested at an annual interest rate of 2.34% and the interest was compounded monthly. All right, let's take a look at what we already know. We know we have a principal of $12,000. We also know the time is 8 years. We know the interest rate is 0.0234. We're told it was 2.34%, but as you know, to change the percent to a decimal, you drop your percent sign, move the decimal point 2 places to the left. So as a decimal, it would be 0.0234. And n is the number of compounding. So here is compounded monthly, so that means n is going to be equal to 12. And for n compoundings in a year, we always use this formula. A is equal to P times 1 plus R over N, and that quantity is raised to the N times T. So all we need to do here is just go ahead and substitute those values in. So here we got A is equal to P, which is 12,000, times 1 plus R, which is 0.0234, raised to the N, which is 12. And that quantity is going to be raised to the N times T. Here N is 12 and T is 8. So it'll be 12 times 8. Now, if you want to, you can go ahead and do the 12 times 8, which will give you 96. So I'll rewrite this as A is equal to 12,000 times the quantity 1 plus 0.0234 over 12 raised to the power of 96. And from here, we can enter this in the calculator. So here's the calculator here. We'll type in the 12,000 times, and then left parentheses, 1 plus 0.0234, and that's divided by 12. Close the parentheses. Now, what's in the parentheses will be raised to the 96 power, so we'll use our caret key for the exponent, and then 96, and then hit enter. We're dealing with decimal amounts, so we want to round to 2 decimal places, so it'll be $14,467.78. So that's the amount in the account after 8 years, $14,467.78. That represents the balance on an account after 8 years if $12,000 was invested at 2.34% interest compounded on a monthly basis. Question number 3. Here we want to find the balance on an account after 8.9 years if $150,000 was invested at an annual interest rate of 4.65% and the interest was compounded continuously. Okay, so here in this case here, the amount in the account is not the amount, the principal is $150,000. As the amount is what we're trying to find. The time is 8.9 years. The interest rate is 4.65%, but as a decimal, it would be 0.0465. Now, in this problem, it says compounded continuously. So now we have to use this formula. A is equal to P times e to the RT. That's the formula for continuous compounding. And then we'll replace those values in this particular formula. P is 150,000 times e to the r, which is 0.0465, times t, which is 8.9. I'm going to put this in parentheses here because this expression can be placed in the calculator. So in this case here, we're going to type the 150,000. Now for the e, if you recall, we use second and the ln key. Second ln for e to the x. And you should get e to the caret with the left parentheses there, and then you can type in 0.0465 times 8.9, close parentheses, and then hit enter. So this will be $226,894.53. That's the amount in the account after 8.9 years if you have $150,000 invested at 4.65% annual interest compounded continuously. $226,894.53. Sorry. Question number 4 is just doing some evaluation using the log key and the LN button on your calculator. In part A, you got log of 962. Okay. On that calculator, you just press the log key, which is right above the LN key. Just press the log key, and then 9.62, close parentheses, and then hit enter. Now to 2 decimal places, it'll be 0.98. So the log of 962 will be 0.98. Part B is finding the 5 times the ln of e to the 13 plus 7. Using your calculator, we press the number 5, and then for the ln, we press the ln key at the bottom, and then for the e, notice we want to press second and ln for your e, and then press the number 13. Now you have to close the parentheses around the number 13, and also you got to close the parentheses again for this first parentheses that follows, that's right after the ln expression, and then plus 7. And that would give you 72. So in this case here, 5 times the ln of 13, ln of e to the 13 plus 7 gives you 72. Part C is the log of the quantity of 41.3 divided by 20.9. In this case here, we press the log key and then type in 41.3 divided by 20.9, close parentheses. And that will give you, now we're going to round to 2 decimal places, so 2.95 would be 0.30. So the log of the quotient of 41.3 and 20.9 would be 0.30. Part D, you got the log of 41.3 divided by the log of 20.9. Using a calculator, we type the log of 41.3. Now you want to close the parentheses because you're only taking the log of 41.3. And whatever that is going to be divided by the log of 20.9. So press the log key and then 20.9, close parentheses, and then hit enter. To 2 decimal places, it'll be 1.22. So this expression will be equivalent to 1.22. Part E, the log to the base 8 of 90.2. Now you're told to use the change of base property. In this case here, if you remember, the change of base property is going to be the log of this number, that's 90.2, divided by the log of the base that's given to you, which is 8. Now you could use ln of 90.2 and ln of 8. Either way, you're going to get the same answer. So if we do log of 90.2 divided by the log of 8, on the calculator, press the log key, and then 90.2. You're going to close the parentheses there, divided by the log of 8, close parentheses, and then hit enter. You're going to get to 2 decimal places, we'll say 2.17. Okay, so here, using the change of base property, the log to the base 8 of 90.2 will be 2.17. Okay, question number 5. Here we're going to find ln of 9 times 7 and ln of 9 plus ln of 7. And we want to prove that the product property of logarithms by making sure that both values are equal. All right, we're going to do ln of 9 plus 7. So in this case, we press the ln button, and then 9 times 7, close parentheses. That's going to give you to two decimal places 4.14. So ln of 9 times 7, that's going to be 4.14. And then you're going to do ln of 9 plus ln of 7. So here, you press the ln key of 9, then close the parentheses, plus, then press the ln key, and then 7, close parentheses, and then hit enter. As you can see, it's also 4.14, rounded to two decimal places. So here, because both the expressions give me the same answer, I can say that the log of the product is equivalent to the sum of their individual logarithms, which is, of course, if you remember, log to the base b of m times n. That's always going to be the sum of their individual logarithms, log to the base b of m plus log to the base b of n. So here, ln of 9 times 7 does give you the log of 9 plus the log of 7. So here the log of the product is equivalent to the sum of the individual logarithms. Question 6. Log of 83 divided by 12 and the log of 83 minus the log of 12. And we want to prove the quotient property of logarithms by making sure that both values are equal. Well, let's do the log of 83 divided by 12. Press the log key, and then you're going to do 83 divided by 12, and then close the parentheses. And then you're going to hit enter. Now, the two decimal places, that will be 0.84. So the log of 83 divided by 12 will be 0.84. And then we'll do the log of 83 minus the log of 12. So here, we press the log key, and then 83, close parentheses, minus log 12, close parentheses, and then hit enter. And it's the same answer, 0.84, rounded to two decimal places. So here, since we got the same values for these two expressions, we can conclude that the log of the quotient is equal to the differences of the individual logarithms, which means that the log of 83 divided by 12 will give you the same answer as if you did log of 83 minus the log of 12. So here, the log of the quotient is equivalent to the differences of the individual logarithms. Question 7. Find ln of 6 to the fourth and 4 times ln of 6. And you want to prove the power property of logarithms by making sure that both values are equal. In this particular case here, we'll find ln of 6 to the fourth using a calculator. Okay, we press the ln key, and then 6 to the fourth, we use 6, press 6, and then the caret key for your exponent, and then 4, close parentheses, and then hit enter. That will be 7.17, rounded to two decimal places. Okay, and then 4 times ln of 6. Okay, we're going to press 4 and then times ln 6, close parentheses, and then hit enter. Notice it's the same answer, 7.17, rounded to two decimal places. So here, we came up with the same answer. That means that the log of an expression to that power is going to be the exponent multiplied by the log. which means ln of 6 to the fourth. That means the 4 goes in front of the ln, which will be 4 times ln of 6. That's the power property of logarithms. We put the exponent in front of the log, or in front of ln. Question 8 is an exponential equation where you're going to have to solve it algebraically, and then you have to write down each particular step that you have done completely, and then show your complete work. Here we got the exponential expression e to the x minus 4 is equal to 7. Okay, that's the original equation that you start off with. Okay, since I know that e and ln are inverses of each other, the best way to solve this one is to take the natural logarithm on both sides of this equation. So what I'm doing here is taking the ln on both sides. Okay, and then I apply the properties of natural logarithms, where the fact that ln of e to whatever that exponent is that exponent. So ln of e to the x minus 4 is simply x minus 4. That's equal to ln of 7. Okay, so here this is just a property of logarithms where ln of e to the exponent is that exponent. Now I want to get the x by itself. I'm subtracting 4, so I need to add 4 on both sides. So what I'm doing here is add 4 to both sides. And then you'll have x is equal to ln of 7 plus 4. And in this case here, when we use the calculator to evaluate ln of 7, then plus 4, we press ln and then 7, close the parentheses, and then plus 4 is equal to, we're going to say 5.95 to 2 decimal places. Okay. So here basically I'm just simplifying. So this is how you will solve this particular equation algebraically. But in this case, you'll have to write out what you just did for each particular step. All right, question 9. Part B, I'm sorry. Solve this equation using a graphing calculator by making graphs of each side and finding the x-intersection. Draw the shapes of both graphs. So here, the left side of the equation for y1 will be your left side of the equation, e to the x minus 4. y2 will be the right side of the equation, which is 7. So here, we're going to press y equal. Let's clear this equation out. y1 will be your e to the x minus 4. For e to the x, you press second and ln. And then your exponent is x minus 4, so you hit xt theta for your x minus 4, close parentheses. Use your down arrow key to go to y2. And just type in the number 7. And then press zoom 6. Okay, and there's the graph. Okay, now you want the intersection. So we're going to press second and trace. We're going to select number 5 for the intersection. Now, where it says first curve, you want to put the blinking cursor close to that point of intersection as you possibly can. And I'm using the right arrow key to do that, because I want to get it as close as I can to that point of intersection. Then press enter 1, 2, 3 times. That's going to be your intersection. And notice the x value in this case is 5.9459101. That's the same as 5.95. Okay, so in this case here, our x value, or our point of intersection, was 5.95, which is exactly what we came up with when we solved it algebraically. As I'm sure they want on your calculator activity, you're going to have to draw the graph on paper as well. Yeah, on paper. So this is what the graph would look like. Question 9 is another equation. This one's a logarithmic equation. Now I won't write out the steps that I did, but I'll just do it algebraically. And for the steps, you can look at the practice or the sample calculator activity that's going to be posted on Cruiser for you to look at. It says here, solve the logarithmic equation log of x plus 4 minus log of x equals log of 4. We're going to solve this algebraically, and we're going to show our complete work. First thing I see is a minus sign. That tells me I have the differences of their of their logarithms, which can be condensed as a log of the quotient. Okay, so here, the left side, I'm going to condense that as a single logarithm, as a log of x plus 4 divided by x, because the differences of their logs is equivalent to the log of the quotient. So this will be log of x plus 4 over x equals to the log of 4. Now in this case here, I have logs on both sides of the equation. Here I can use the one-to-one property. Since I got the logs on both sides, I can set this expression equal to this term right here. I'll take that x plus 4 over x and set that equal to 4. Here I'm using the one-to-one property. Now I can solve this equation for x. Let's get rid of the x in the denominator by multiplying both sides of this equation by x. So here these will divide out, these x's will divide out. You'll have x plus 4 is equal to 4x. And then to get the x's on one side of the equation, I'm going to subtract x on both sides. So that means I'm going to have 4 is equal to 3x. And then to get the x by itself, divide by 3. You'll get x is equal to 4/3, which is equivalent to 1.33. Because we know it's 1.33 repeating. Okay, so that's how we will solve this particular equation. Now we can also check by using the graphing calculator by making the graphs of each side and then finding the x-coordinate of the intersection. Now here we're going to change the window from -3 to 3 for the x and -3 to 3 for the y. Okay, so here, let's go to y equal. I'm going to clear both of these equations out. Now, the left side is going to be the log of x plus 4 minus the log of x. So under y1, I'm going to press log and then x plus 4, close parentheses, minus, then press the log key of x. And then for y2, I have, on the right side of the equation, I have log of 4. So we'll use that as y2. Press the log key and then 4, close parentheses. Okay, now we're going to change the window here. So let's press the window button next to the y equal. My x-min is going to be -3. X max is going to be positive 3. I'm going to let X scale remain as 1. Then for Y min, that's negative 3. Y max is 3. Y scale will remain as 1. Press the graph key. And that's what the graph looks like. Now we want to find the intersection. So we'll press second and trace. Select number 5 for the intersection. Now that first point, let's see where that blinking cursor is going to be. Okay. Let's put it as close as we can to that point of intersection. And then press enter 3 times. And as you can see for the x, we got 1.33 repeating. That's the same thing as we came up with. So here, the x is approximately 1.33. Okay, so you know for y1 was log to the x plus 4 minus log of x. And then y2, which is simply the log of 4. Finally, question 10, also A and B. The A part is solving it algebraically. Okay, now I won't do the written description. You can look at that on the sample calculator activity that is on Cruiser that I'll be posting within the next few days. So here we got this logarithmic equation, log of 70x plus 60 minus log of x equals 2. Now we don't have a log on the right hand side of the equation, so we can't use the one-to-one property. However, we do have the minus sign between the two logs. Again, that's the differences of their logarithms. That means we can condense that as the log of the quotient. So we'll rewrite this as the log of 70x plus 60 divided by x. And that's equal to 2. Now, since we don't have the log on the right-hand side of the equation, we're going to have to rewrite this as an equation in exponential form. Okay, there's no base here, so that means that it's a 10. It's understood to be a 10 because it is a common logarithm. If there's no base written in this particular for logarithm, it's understood to be a 10. So it's log to the base 10 of 70x plus 60 divided by x equals to 2. We're going to convert this into its equivalent exponential equation. So here our base is 10. The exponent for the 10 will be 2. So it'll be 10 to the second equals to this expression, 70x plus 60 divided by x. That's how we convert from a logarithmic equation to its equivalent exponential form. Now let's go ahead and simplify this. 10 to the second, that's 100, is equal to 70x plus 60 divided by x. Now let's get rid of that x that's in the denominator by multiplying both sides by x. Here these x's will divide out. I'll have 100x is equal to 70x plus 60. And then to get those x's on one side, I'll subtract 70x on both sides, which means I'll have 30x here is equal to 60. And then divide both sides by 30. We'll have x is equal to 2. Now I'll leave the check up to you. So x equals 2 is the solution to this logarithmic equation. Okay, now we're going to use that same equation in the graphing calculator. We're going to make graphs on each side by finding the x-coordinate of the intersection. Our window will be from 0 to 10 for the x, 1.5 to 2.5 on the y. So y1 when we enter this in the calculator, will be the log of 70x plus 60. Y2 will be, minus the log of x. I'm leaving that part out. Log of 70x plus 60 minus log of x for y1. Y2 would just simply be the 2. So in our calculator, let's select y equal and clear these equations out that we already have. Y1 will be the log, and then 70x plus 60, and then close the parentheses, minus log x. Log x. Close parentheses. Hit your down arrow key, go to y2. Y2 is just simply going to be 2. So we just enter the 2. Now let's change our window here by pressing the window key. Our x min is going to be 0. X max is going to be 10. The x scale will remain as 1. Y min is 1.5. Y max is 2.5. But I'm going to change the y scale to 0.5 since we got 1.5 and 2.5. So let the y scale be 0.5. And then go ahead and press graph. And that's what the graph looks like. Now the next step would be to find where those two graphs intersect. It's at this point. Press second and trace. Go to intersect, select number 5. And then for the first curve, you want to put the cursor to the intersection as close as you can. I'm using the left arrow key. And it depends upon where your cursor is at. Then press enter 3 times. That's 1, 2, and 3. Notice your x-coordinate is 2. Your x-coordinate is 2. So here, we came up with x is equal to 2 on the calculator the same way as we did this algebraically. Okay? So this should be enough to assist you with some of the calculated activity problems that are on Campus Cruiser for you to complete. Also, feel free to come by my office or ask questions if you need to, or send me an email if you have any particular questions.